So this is the video presentation of my created Lex Analyzer program, which is to identify the user input characters, special characters, and numbers. So we were assigned a task, which is a programming language project to build a lexical analyzer for a programming language of your choice, which it can be in a subset of C, Python, or Java using Flex. So this analyzer program should be able to recognize and classify all the lexical elements of the language, which is keywords, identifiers, literals, operators, and punctuation symbols. So um, the program can also include a support for error handling. So if a user input a characters, special characters, or any sort of things that is not that will not follow the section rule or the pattern in the program, so the program will identify and invalidate those characters and will display syntax errors, invalid tokens, and will also produce a formatted output of the analyzed code. So aside from that, if the user input text, characters, numbers, special characters um, in one string. So for example, in one string, there is special characters, numbers, or letters. So the code will dissect and analyze it by subsectioning or sorting and display it, in which it will identify in that string who is the identifier, who is the assign, who is the integral literal, the closing parenthesis, if there is any. So the program will do that kind of job. So again, this programming language project is a lexical analyzer program, which is to recognize, identify, classify the lexical elements of the language, special characters, letters, and numbers. So before running that code, so I will explain this lexical analyzer program. So first and foremost, this is the header for the top part of the code, which has the include stdio.h, include stdlib.h, and the include string.h. This header or this part of the program is very important for this program, since in this code, this is a subset of C language. So every C program has this standard header, because this header or this function is responsible for input and output, also for memory management of the code, and also the overall manipulation of this code. And this part, the option no YY wrap, this option no YY wrap is all about controlling the analyzer Lex program to deactivate the YY wrap default function. So since YY wrap is default function, so we have to invalidate it so that this Lex Analyzer program will work. So if we will not deactivate that YY wrap default function, so this program won't work. So this part is marked in the beginning of the rules section of the code in Flex that have a pattern action to be followed or to be identified by the code itself. So when a match is found, those actions are matched with the user input character. So the code will analyze those users input characters, special characters, and numbers. So as you can see, the code started with $%, which is this is the start of the code to be analyzed. So this is the rule section or the pattern of this code, of this Lex Analyzer code in order to function the code. So if a user input a string of small and capital letters from A to Z and numbers from 0 to 9, so the token or this program will print a token of identifier, which is which I mean these characters that you input or the user's input is will be classified as identifier. So if a user input a numbers from 0 to 9, it can be a one number, two numbers, three numbers, or any numbers. So the program will identify and print integral literal. So it will identify as integer literal. Sorry for that. And if the user input is equal, so the program will recognize it as a sign, since equal is more on assigning encoding. And if a user input is plus, and then the program will identify and recognize it as plus. And if a user is input this minus sign, then the program will display this minus. And if a user type asterisk, so the program will identify and recognize it as multiply because asterisk is a symbol of multiplication. And then if a user input is forward slash, then the program will identify and recognize it as divide, since forward slash means to divide or a symbol of division. Another, if a user input percentage, so the program will recognize it as modulus, since percentage is a modulo or a modulus sign. And if a person, I mean if a user type this raise or power sign, then the program will print the message and identify it as power. Another, if the user input parentheses, either an open or close parentheses, then the program will identify it as opening and closing parentheses. And if a user input a combination of this string literal, then the program will display a string literal, which is a combination, or in one string there is amount of literals combined. And if a user type this kind of literal, then the program will print and recognize it as character literal. And if a user type a comma, and then the program will identify it as tuple. And then if the user type a character or a set of characters with white space or with space in it, and then the program will just ignore that white space, and nothing to worry about the codes or the string of the characters, because it will just ignore by the program. And then if the user type a special characters that is not included in this rule section or in this pattern, and then the program will not recognize it and will print this message, which is an invalid character because it doesn't imply or doesn't go with the rule section, which is this pattern. And then as you can see, we have here this double %, which is to end the rule pattern or to end this section of the code, which is it's already done, which is this is the rules to be followed. And as you can see here, since we have ended, we have to initialize main as the main function of the program, and then the YYLEX, which is also to initiate. The YYLEX is also put here to initiate the lexical analysis process of this code. And then return 0, we will return 0, which means that the code is successfully run by us, by the user, or by the programmer that will run this code. So that's the lexical analyzer code for this. So to run this code, we will open a terminal. So you can use a terminal in in Visual Studio Code if you use Visual Studio Code. If not, you can also use a command prompt terminal. So before anything else, we need to have GCC and Plex in your system. So to validate if you have GCC and Plex in your system, we will just type GCC to check if it has GCC in your software. And if you receive this kind of message, so it means that you have GCC in your system. Another to check is the Plex software. So if you receive this kind of blank output, it means that you have already Plex on your system. So running again. So we will now run this code. So first of all is we have to type the Plex and then the file name. So to run the program, we will locate the file where it is saved. So sa akin, ang program is saved in my drive D, which is mag-change ako ng directory, which is the file name of the folder is my projects. I mean final project. And before anything else, we just need to type Plex, the file name of the code. In my case, it's Lideros underscore capital finals and the extension which is L. Press enter. And then, as you can see here, the program generated this lex.yy.c, which is another code or the overall explanation or overall explanation and the detailed flow of the program. And after typing Plex and then the file name of the code, so we will just GCC the generated lex.yy.c file. So we will input GCC lex.yy.c, press enter. And if you can see, again, in the folder, it generated this a.exe program file because this is the created program that you have to run in order to run this code and its functionalities. So we will just type the file name of that Plex program file, so A, and then if you receive this blank output again, so it means that you are ready. You can now use the program and type the characters needed in order for the code to identify if it is an integer literal, a multiplication, a division, and so forth and so on. So first we have to type, for example, letter A, and then as you can see, the program identifies A as identifier. Another B, BF, BDG. So the BFG identified and recognized by the program as identifier, because that's what that is what this pattern's rule has. Another is for example, we type string of numbers, and then the program will identify 1, 2, 3, 4 as integer literal. Another is percent sign. So as you can see, the program identified as modulus. It means that percent is a modulus because it is that's what written in the program code. Another, for example, a string of number, character, and special character included in the in the program. So as you can see, the program dissect those characters, and it analyzes that 1, 2, 3 is integer literal, the DFG is identifier, the forward slash is divide, and the modulus will be the percent. So what if we type a streamline of characters with numbers and special characters and adding a character that is not included in the rule section? So what it will be happen? So the program will still identify those characters that is included in the pattern, such as the QWRTR435 is the identifier, the modulus is the percent, and the forward slash is divide. However, the last character here identifies as invalid character because it doesn't contain, the rule section in this program doesn't have a question mark, so it identify and recognized by the program as invalid character. So another, what if we type another special characters like this key? So the program will dissect and sort that to E-like letter, and it will invalidate as invalid character because this E sign is not included in this rule section or pattern of the code. So this is the end of this code presentation. This is a Lex Analyzer program, which is to analyze, recognize, tokenize, and identifying the characters, special characters, integer literals, identifiers, and so on in the program, which is a user type characters. So I am Ricky Lederos, and thank you for watching.